Okay, so here we are out in Thompson Woods, and today's exercise is to learn how to take a cross-sectional area measure of soil erosion. So I've got a very simple field setup running here. We've got a stake on one side of the trail. At the edge of, not the trail, but that spot where the soil has a natural sort of height, and then in the trail it's been eroded out, so you can see there's space underneath the tape. So the stake on the one side is where that transition from natural soil height starts dropping down to gullied out erosion. Same thing with the stake on the other side. So these stakes are not at the edges of the visible trail where there's exposed and compacted soil. It's where the curve of the shape of the soil starts to dip down into where the soil has been eroded away in the trail surface. So we're strung out perpendicular to the direction of the trail here, and our first measurement is going to be what's the width from one stake to the other. In this case, it's at 1.4 meters, which is going to be a little over 4 feet, and a little over 48 inches, about 50 inches wide. And then our next move is going to be to get the area of what used to be soil, but is under the tape, under the original soil surface, down to where the actual soil surface is now. So we take a second measuring tape and we measure down vertically from the tape to the soil surface at several intervals. So you gotta note two things after you note the width of the trench or the erosional gully. The first thing that you note is how far from the first stake is the depth measurement happening. So in this case, we have at 0 inches, at 6 inches, 1 foot, 18 inches or 1.5 feet, 24 inches or 2 feet, and so on until we get to the other stake at about 50 inches. The second measurement at each one of those width progressions is the depth. So here we have a depth at 6 inches across of about 2 inches. So we have a triangle formed from the stake and the tape meeting the soil surface. The width is 6 inches, the depth is 2 inches, and 6 times 2 is the area of that space. But it's a triangle, not a rectangle, so we divide that multiplication in half. So 6 times 2 divided by 2 is going to give us 6 square inches. Okay? And then we repeat that for the next one. So we have 2 inches of depth at 6 inches. We have, this is about 3 inches of depth at 12 inches width, or 1 foot along from the stake. We have an extra inch down. So now we have not a triangle, but a trapezoid. And the one depth of the trapezoid is 2 inches. The second depth of the trapezoid is 3 inches. The width of the trapezoid is 6 inches, from 6 inches to 12 inches. So 6 inches. Okay? So this is all very simple math. We're just taking what's the area of the little geometric figure swept out by missing soil underneath the tape line. Rinse and repeat this process to get a triangle on one end, a trapezoid, 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 triangle on the other end is usually how this works. And then you just add all of those up. That's the whole thing. So it helps to have a partner to do this exercise. One person setting up the stakes and taking measurements, the other person recording the measurements in a very systematic way so that both of you, after the field work part is done, can use the Excel spreadsheet or whatever notes you've taken to compute the area of each of these triangles and trapezoids, and then just add them up. And the sum total is all of the area that used to be filled with soil but is now open air down to the current soil surface. So the soil that was here is now no longer here. So this is sediment being taken up by overland flow, washed straight down the slope behind me into the creek bed below. So what this measurement does, why it's useful, is for helping us understand to put a number to how many cubic yards, how many dump truck loads, how many cubic kilometers in a larger area of soil has been lost or put into the wrong ecosystem, the stream ecosystem instead of the forest floor ecosystem, as a function of our recreation and our recreation management. So that's the whole thing for cross-sectional area. There's some wrinkles and ins and outs with looking at direct slope or direct ascent, trails that run straight up a slope like this one, versus trails that are running side hill and have maybe some soil removed in the trail construction process beforehand. But for the purposes of this exercise, we're just going to keep it simple and measure from one stake to the other the erosional width, and then at fixed intervals along the tape from one end to the other, the depth of those erosional incision measurements or depth measurements. Add those areas up and you have the space that is swept out by the erosion. Multiplying that space as a final operation by the length of the trail to the next measurement that you do, that gives you a volume. So we have cross-sectional area computed as the sum of areas of triangles and trapezoids, and then multiply that by, let's say we do the next one 100 yards further along the trail. On average, the actual volume of soil, not just the area, but the volume that's been moved into the creek, is the area that you've computed times the distance to the next point, volume.